Semiconductors are pretty much the brains and the heart of every single modern electronic device we use. But here's the thing you might not realize. Not all of those silicon brains are created equal. Not even close. They are highly, highly specialized, and they've evolved for the very specific jobs they need to do. So let's dig into how that actually works.
So picture this. You've got a high-end gaming PC, a super sleek smartphone, and a massive AI server humming away in a data center. Each one is powered by semiconductors, right? But the chips inside them are fundamentally different. You couldn't just swap them out. A PC chip in a smartphone, it'd be a disaster. And a smartphone chip trying to run a huge AI model? No way. So what's the deal? Why are they so incredibly different?
Well, the answer is actually pretty simple, but it's also kind of profound. The purpose of a device, what it's meant to do, dictates pretty much everything about the design of its semiconductor brain. It's really all about matching the chip's personality to its job.
If you zoom out, you'll see that chip design is really driven by three very different philosophies. For a PC, it's all about raw, brute force, high-performance computing. But for a smartphone, the focus completely shifts to low-power integration, making everything super efficient and cramming it into a tiny package. And then you have AI, which is just a whole different ballgame. It's about achieving massive, almost unimaginable parallel processing power.
All right, let's kick things off with a familiar workhorse, the personal computer. This thing is a true power generalist, designed to do a little bit of everything and do it really, really fast. Think about what a PC has to do. Its whole reason for being is versatility. One minute you're editing a 4K video, the next you're jumping into an intense gaming session or running complex code. So what does that mean? It means you need raw power and flexibility, no compromises. So how does the PC solve this? Well, its solution is to use a team of specialized high-performance parts that you can upgrade and expand whenever you want. Peak performance is the absolute priority, way more important than power efficiency, because, well, it's always plugged into a wall, right? At the head of this team, you have the CPU, which you can think of as the general purpose commander. Its job is to process a huge variety of complex instructions, one after another, but at incredible speeds. You can really think of it as the master strategist, calling the shots for the entire operation. And right there, working alongside the CPU, you've got the dedicated GPU, the screen expert. Now this is a key difference. The CPU is your jack of all trades, but the GPU? It's a hyper-focused specialist. It's designed to do thousands of pretty simple calculations all at the same time, which just so happens to be perfect for rendering those stunning graphics in your favorite games. Okay, so that's the PC. Now, what happens when you try to cram all that power into something that fits in the palm of your hand? This is the world of the smartphone, the true efficiency expert. Yeah, the smartphone throws a whole new set of challenges into the mix. You've got a very limited battery and a tiny, tiny amount of physical space to work with. Suddenly, peak performance isn't the only game in town. Now it's all about extreme power efficiency and just making everything as small as humanly possible. And the answer, which is actually pretty brilliant, is integration. Instead of that big team of separate parts like in a PC, you just fuse everything together into one single, highly compact, energy-sipping package. And that brings us to the System on Chip, or SoC. People often call it the all-in-one chip for a good reason. It takes the CPU, the GPU, the 5G modem, AI processors, you name it, and basically crams them all onto one tiny piece of silicon. This design is absolutely crucial for getting the most out of your space and your battery life. And this is a fantastic way to see the difference in philosophy. On the left, you've got the PC's modular RAM. You can pop it out and add more whenever you feel like it. On the right is the smartphone's memory. It's a special low-power DDR RAM, and it's soldered directly onto the main chip to save every last bit of space and energy. It really paints a clear picture of the trade-off you're making, right? You give up that ability to upgrade, but what you get in return is amazing efficiency. All right, time to shift gears one last time and talk about something that operates on a completely different scale, the AI data center. This is a true parallel powerhouse. Whenever you ask an AI like ChatGPT a question, the number of calculations happening behind the scenes is just staggering. So the problem here isn't flexibility or battery life, it's just pure mind-boggling scale. How on earth do you build a system that can handle the trillions of operations needed to train and run these massive models? And the solution? Well, it's pretty much what you'd expect. Overwhelming power on a scale that's hard to even imagine.
We are talking about massive data centers, basically farms, packed with thousands of highly specialized chips, all working together. And their one and only goal is to achieve absolutely mind-blowing parallel processing performance.
And the undisputed king of AI training is something called the GPGPU, or General Purpose GPU. So here's the cool part. A while back, some really smart engineers realized that the GPU's knack for doing thousands of simple calculations at once for graphics was also perfect for something called matrix math. Now, matrix math is just the fancy term for the complex, simultaneous calculations that are the very heart of how AI learns. So what did they do? They took the GPU, stripped out all the stuff it needed for making pretty pictures on a screen, and maximized its raw number crunching power just for AI. But of course, making these AI chips so insanely fast creates a whole new problem, a data bottleneck. They just consume data way faster than traditional memory can feed it to them. The solution is something called high bandwidth memory, or HBM. Think of it as an ultra-fast data refueler. It's a super clever design. Instead of laying memory chips out side by side, it stacks them vertically like a skyscraper. This creates thousands of data lanes to feed these hungry AI processors at lightning speed. Okay, so we've taken a tour through three completely different worlds: the powerhouse PC, the efficient smartphone, and the massive AI data center. Let's pull it all together and see how form really does follow function. And this table here, it really ties everything together perfectly. On one hand, you've got the PC, built for high performance, with its modular CPU, GPU, and memory. Then there's the smartphone, totally focused on efficiency, integrating everything into one power-sipping SoC. And finally, the AI data center, engineered for nothing but massive parallel computing, with its specialized GPUs being fed by that ultra-fast HBM. I mean, it's crystal clear, isn't it? Three totally different problems lead to three very specialized, unique solutions. So, what's the big takeaway from all this? It's that all of this is based on the same fundamental semiconductor technology. But, and this is the crucial part, depending on what you need it to do, whether it's for raw performance, strict efficiency, or massive scale, that technology evolves into radically different forms. Each one is on its own specialized evolutionary path. And that kind of leads us to one last really interesting question. We've seen how purpose shapes design today, but as our technological demands get even more specific and specialized, what's the next generation of these silicon brains even going to look like? Maybe we'll see chips designed for just one specific AI task, or chips that can literally reconfigure themselves on the fly for different jobs. One thing's for sure, though, this evolution is far from over.